Okay, I see many clear in the chat area. So let us start today's training. So I assume that most of us have, or most of you have already attended our core function training, which includes CR series and MG400. And by learning the core function training, we can master the basic core functions of our doorbot industrial cobots, as well as the hardware and software function models of the doorbot, which is the Doorbot Studio Pro. And in the advanced function training, we will maintain the many used communication protocols of the doorbot industrial robots, which you can use to let our robots to work with other external devices like PLC, vision system, and etc. And secondly, we will learn the basic and effectors related knowledge, which is compatible with our industrial robots. And thirdly, we will learn the two methods of creating robot trajectory. And last but not least, I will give you a brief introduction to Simba, which is needed when we want to access the robot controller via PC. So that is meaning the 4 parts of today's advanced function training. So before we start, I want to do a little review of the training content in the core function training parts, which is the hardware interface of our CR series robots. As you can see in the left picture, this port is the internet port, which you can use the network cable to connect the robots with your PC. And the default IP address of the CR series robot is 192.168.5.1. And there are 3 default ports of our robots, which I also want to notice. The port of 502 is the fixed port for Modbus application. And the port 29999 is the TCP/IP port, which is used for secondary development. Also, the port 3003 is another TCP/IP port for the secondary development with another function, which I will introduce in the following content. And the related ports at the end arm of the CR robot is the NIO port, which supports the RS485 protocol. Okay. And then we go to our first part, the main communication methods that our industrial cobots support. Firstly, the TCP/IP. So TCP/IP stands for Transmission Control Protocol, or and the Internet Protocol. which is a suite of communication protocols used to interconnect network devices on the internet. As you can see, the IP suite functions as an abstraction layer between the internet applications and the routing and switching fabric. And the TCP and IP are the two main protocols in the entire IP suite. In the transport layer, which is responsible for maintaining end-to-end communications across the network, the TCP and the UDP protocols are the most used two protocols. And the TCP protocol is a connection-oriented communication protocol that helps in the exchange of messages between the different devices over a network. There are three remarkable features of the TCP protocols. First one is connection-oriented. A connection between client and server needs to be established before data can be sent. And secondly, reliable. The three-way shake-hand retransmission and error detection mechanism add to the reliability of the transmission. And lastly, based on bit stream, the data sent by the sender can be read for multiple times, and the data that is sent multiple times can also be received at one time by the receiver. And if you are interested in the detailed information about TCP introduction, we also touched a YouTube introduction video link in this slide, which you can refer after the training. Okay. And as shown in this slide, TCP/IP uses the client-server mode of communication, in which a user or machine as a client is provided a service like sending data by another computer as a server in the network. And this process circle shows the TCP server-side implementation process, which can be divided into 5 steps. Step 1, create a server socket on the server to listen for client request and create bounce ports. Step 2, if there is a request from the client, the server socket connects to this socket on the client to communicate with the client. And step 4, disable the socket communicating with the client. Then it will stop communicating with the current client. And the last step, close the server socket when the communication is finished. Then any new client request will not be accepted by this server. And this slide shows the TCP client-side implementation process, which can be divided into 4 steps. Step 1, create a new TCP client socket. Step 2, establish a connection with the TCP server socket. Step 3, transmit data using the established TCP sockets. And last step, when the data transmission is finished, close the connection. And in this slide, this table shows our TCP related APIs, which are create TCP, establish TCP connection, receive TCP data, send TCP data, and close TCP. And here shows the corresponding APIs. When we want to create a TCP network, we use the TCP create API or a function command. The related parameters need to be set in this API is shown here. The first parameter is each server. When this value is 0, it means we will create a client. And when this value is 1, it means we will create a TCP server by this TCP create command. And the IP is the value of the server IP address. And the port is the TCP server port. And we will receive 2 values when we conduct this TCP create command. First one is the error value. When the value of the error is 0, it means the TCP network is created successfully. And when this value is 1, it means the TCP network failed to be created. And it will also feedback the corresponding TCP socket that you create. And here shows a related command example. And after we create a TCP client or TCP server, then we want to establish the TCP connection by using the TCP start API, as shown here. And I will escape the parameter description, which you can refer later. And I want to introduce the return value of the TCP start command. 0 means the TCP connection is successfully established, and 1 means that the parameters that you put in the TCP start command are not correct, and 2 means that the socket object that you input in the command cannot be found. 3 means timeout setting is incorrect. And 4 is the robot is set as a client. It indicates that the connection is wrong. And if the robot is set as a server, it indicates the receiving data is wrong. So when you use the TCP start command and get the return value, except 1, but 1, 2, 3, 4, you can check this slide to help you improve your command. And we use the TCP read API to read the data that's sent from the other devices. And here is the related set parameters and the return value. And when you want to send data to the TCP client or a TCP server, you can use the TCP REST API, and the corresponding set parameters and return value are also shown here. And here is the example. A little introduction. For example, when we successfully accept TCP communication and want to send data, like the robot is the client and the other device is the server, we just use the TCP REST command and input the corresponding circuits that you receive from the TCP start command, and the data that you want to send here is hey as the string, and the limit time. Usually we set this value as 0 to ensure that the TCP data can be successfully sent to another devices. And after the TCP data transmission, we use the TCP destroy API to close the TCP connection. And this slide shows an example of how to use the TCP IP protocol to transmit data between TCP clients and the TCP server. As shown here, of course, we firstly will create a TCP client or TCP server by use the TCP create API. Then we will try to establish the TCP connection by using the TCP start command. Then we want to send the data to the other side devices, either the TCP client or TCP server. And here we can see that the TCP, the robot is act as a TCP client, and the debugging tool is simulated as a TCP server. So we want to send this data, what we want, to the TCP server. And after the TCP server receive this data, he will try to send the apple to our robot. And then the robot can use the TCP read API to read or receive the data sent from the TCP server. That is the main process. And I will show you a video of the whole process. Please wait for me seconds to open this video. So firstly, we check the Sorry. Okay, and here shows the same scripts that we attach in the PPT, and we open the debugging tool, which is integrated in our Global Studio control software, and we found the debugging tool, the network, and use the TCP server simulator. And here we create a TCP client to let the robots as a TCP client by set this value as false. And then we go to the network and internet settings of the PC to find the TCP server IP address. And set the PC IP address and edit and input and port. So here is the TCP server. Use the same IP of the PC and choose an IP port of the PC to simulate as a TCP server. And now we just successful create a TCP server and listen the data required from the TCP client. Successful listening, and we run this script. You see, after we successfully create TCP client and establish the TCP connection, it will firstly send this string, what do you want, to the TCP server. By using the TCP write API. Then we use this debugging tool to send Apple to the TCP client, which is the robot. See, the robots will receive the data. Here is the Apple from the TCP server by using the TCP read API, and they then get back searching for Apple to send to the TCP server. And this is meaning the case about how we mainly use the TCP related API in our Doorbot application. Okay, then let's continue our next training part. And here also shows example videos of our industrial robots M1 Pro work with the vision system via the TCP/IP communication protocol to grab and place the materials using visual recognition. And in this case, the robot is work as the TCP client, and the vision system is worked as the TCP server. We will learn more about the cooperation via of the robots and vision system in the following content here. And the whole process of the cooperation between our robots and the feature system via TCP/IP is that firstly the camera captures the image, and then we process the obtained image in the vision software, including vision calibration, future matching, calibration transformation, and etc. to acquire the physical coordinates of the detected object. Then the data can be sent from the vision system to the robot via the TCP/IP protocol. And after the robots receiving the coordinates data, then it can conduct the corresponding movement like grasping. And the basic vision kit
Jimmy, if you are talking, we cannot hear you.
Here, do you hear right now? Can you hear me?
Now I hear you.
Okay. And which part do you missing? I can restart from that part.
Probably the wall slide.
Oh, all this slide. Okay. Okay. I will start from this slide. Okay. Okay. So, I think that some of you have already used our basic vision kits, and here is some introduction about that. The basic vision kits from Dobot normally includes the camera, lens, light source, vision software, and other hardware parts. And the vision system is mainly responsible for processing the acquired image and sending the corresponding data to the robot, meaning the physical coordinates of the detected object. And then the robot arm will perform corresponding operations after receiving the data sent by the vision system, like grabbing. And I want to notice that the application of the robot basic vision kit is limited due to the hardware limitations, like the camera. So for detailed application demand, we suggest you contact the local integrators for consulting and confirmation of adaptability. And now I will simply introduce the normal steps to achieving the 2D vision positioning via an example case. And this table shows the many used accessories in this example case. Camera is clearly used to acquire pictures, and there are 3 points you need to do when install the camera. Firstly, adjust the focus of the camera to acquire a clear vision area. If you are using the vision kits from us, you can use the MVS software to set the focus parameters, and also you can by rotating this part to adjust the focus of the camera. And secondly, you need to install the camera properly and stable to reduce the error caused by the tilt or loosening of the lens, as shown here. And lastly, please make sure that there is no disturb to the vision area. And we use the light source to ensure the good light condition in the vision area. The calibration board is used in the vision calibration process to create the calibration file, which can be used to transform the image coordinates into physical coordinates of the detected object. And a calibration tool like the calibration needle is used in the vision calibration process to acquire the physical coordinates of the calibration points in the calibration board. And if you are using industrial camera with the network board, you can use this USB to LAN adapter to set the camera IP address in the same segments of the PC and the robots. And if you are using our doped vision kits, in which the industrial camera is already the USB 3.0 connector, this is not necessary. And the dongle is necessary when using the robot Vision Studio software, which is already in the packing list of our vision kits. And for the 2D vision positioning application process, there are 3 points that you need to notice. Firstly is sufficient light are needed for the camera recognition area. So we use the light source. And secondly, you need to make sure that there is no blocking in the vision area when taking photos. And lastly, you need to make sure that there is no obstacles to block the robots when it's movement. And this slide shows the main steps that we achieve the 2D vision position application. Firstly, we use the camera to create an image source, which will obtain the calibration board or the detected object. Then we do the vision calibration to create the calibration file. Next step, we will create the feature tablet of the to be detected object or to be grabbed object and acquire the image coordinates of the object center point. And lastly, we use the create calibration file to transform the image coordinates of the object's center point to its physical coordinates and translate and send it to the robot. And this slide shows the main page of the Doorbot Vision Studio software. You will open when you open the Vision Studio software. We normally click creation solution, generate solution, and enter this main editing page. As shown here. And after we create a general solution, we firstly want to establish or create the TCP/IP connection by click the communication management. And in here, we will create here, for example, a TCP server, which is the vision system, and input the IP address of the PC. Here is the point. The vision system is using the same IP address of the PC and input the IP port of the PC. Then we click create to create the TCP server. And here shows the corresponding TCP related API that we will use in our robot script program. And to notice that the TCP server can be created individually, waiting to be connected, which is in listening status, while the client must run when the server has been created. And for the about the question from Syncuxy, auto calibration is supported by our CR robots. And if you wanted this solution, please send email to Hans, and we can send the demo to you. Okay, and after I finish this part, we will make a little rest and the Q&A part for like 15 minutes. And once you successfully create the TCP server, you can also use the debugging tool, as I has shown you in the past training content, and find the network and choose the TCP client simulator and input the TCP server IP address and the server ports that you just created, and do the testing. As you can see here, after successful connection, you can try to send data in the Fission software, and the debug tool will receive the data. Okay, so first step, we successfully create the Fission system as the TCP server. Then we do the second part, which is the Fission calibration. To finish this part, we need the following things, like calibration board, calibration tool, which can be the calibration needle, and sufficient light condition, and sufficient work area for the robots, and the standby position of the robot should be offset the camera view. Here is the example of the cooperation between the Fission system and our industrial cobot MG400. And another important thing that I want to notice when you do the Fission calibration is that during your Fission calibration process or the whole Fission application, please make sure that the position of the MG400 and as well as the hardware Fission system are fixed during the whole process. Because once the position is changed, the Fission, the image coordinate system, or the robot physical coordinate system is also changed. It will influence the accuracy of the whole Fission and co-op and the robot system. Okay, to achieve the Fission calibration, we mainly use the 3 blocks in the Fission Studio software. The first block is the camera, which is used to obtain the image, and the second block is the calibration board, which you can find in the calibration function model. This part is used to acquire the needed calibration points from the calibration board. And the last block is the endpoint calibration, which is used to acquire the image calibration points and then input the corresponding physical coordinates, as shown here. Firstly, we choose the camera image block and choose the corresponding camera that you install in the Fission system, and go to the and choose the software as the trigger source. It means that if you want to take a picture, you just need to click run once, then it will take the picture.
Recording in progress.
And then we go to the second block, the calibration board. You just need to put the calibration board under the in the vision view, and it will automatically acquire the calibration point from the calibration board. As shown here. Then we make the settings of the third block, which is the endpoint calibration. The only thing you need to edit is the translation times. For the MG400 and CR, when you use the calibration board to do the vision calibration, we suggest you input 9 in this value, and then click conform, and go to the main page to click run once. Then it will automatically acquire the 9-point image coordinate values from the calibration board. And the next step you need to do is to input the corresponding physical coordinate values via the robot control software, which is the Robot Vision Studio. And the sequence of the calibration points you need to refer to is this pass line as shown here. And after you input all the 9-point calibration points physical values from the control software, then click OK to create the calibration file. And for the users who are using the Robot Vision Studio 4.1.2, the software version, before you click the create calibration file, please firstly click execute, then click the create calibration file. Otherwise, the calibration file that's created will be wrong. Okay, that's all about the vision calibration process. And through the vision calibration process, we will in the end create the calibration file, which can be used to transform the image coordinate values of the detected object to the physical coordinate values. And in the next part, when they do the feature matching and the physical coordinates transformation. So firstly, we add the camera block in another floor, then fast match. Camera is simply to acquire the picture of the to be detected object. Then we add a fast match. This is used to create a future tablet of the to be detected object and detect its center point. And to create the future teleplate of the to be detected object, we double click the first match and choose the future calibrate. Then click create, and this picture is the picture or the image captured in by the first block, which is the camera, and we use the function choose here to select this object, and then it will automatically create a future tablet of this object, and you can use this icon to define the center point of the to be detected object, which will input the image coordinate of this point, and we via the fast match block. And after we successfully create the future tablets of the to be object, to be detected object, every time the object is under the vision area, and you take a picture to acquire the image, it will automatically detect this object and input the image coordinates of this object center point as shown here, and also the degrees of the angle degrees of this object. So as I just mentioned, via the fast match block, we can detect the to be detected object center point via creating a future tablet, and it will input the image coordinates of the center point. Then we can use the calibration transformation block to transform the output image coordinates of the detected object from the fast match block into the physical coordinates. And the settings you need to do with the calibration transformation block is simply double clicking this block and find the load calibration file option, then open the calibration file that you just created in the vision calibration process, then click conform. So the calibration transformation block, we successfully transform the image coordinate values to the physical coordinate values of the detected object center point. And then we use the format to ordinate the data, the sent data format of the data. Here, for example, we want to the first sent data parameter as the x physical coordinates of the detected object center point. The second parameter is the y coordinate value, and after the split symbol that we use is comma. After we successfully organize the data form that we want the vision system sent to our robot, then we do the next step is choose the communication devices by using the same data block. And we just need to choose the output option as the communication device. And the communication device is just the TCP server that we create in the first step. And the same data is the data format that we organized via the format block. After word setting, we can click run, and the data sent to the robot can be checked in this windows. As here shows, the x coordinate is this value, and the physical y coordinate value is this. And also we can use the debugging tool in the Double Studio Pro to check the whole process as shown here. Okay, and there is another little practice that can be achieved via the vision system and the robot, which is the same as the first practice I introduced you in the TCP/IP training content. Okay, I think that is all about our first part, the introduction of the TCP/IP, and we do the first Q&A part. And if you have any further questions that Hans doesn't answer you via a chat room, in the chat room, you can read them up by unmuting yourself or just typing in the chat room, and I will check it, answer you. And if you don't have questions about the past training content, we can take a rest for 15 minutes. And about the process of the vision and about the process of the vision application, we will also establishing a training video in the end of the November, which I think will better help you to know how to conduct this process by yourself. Yes, and the vision software, Adobe Vision Studio, needs to be running on the PC or industrial control machine. And as I just mentioned, so the process of the whole vision application case is a little bit complex or difficult compared to other applications such as palletizing. So we are making a training video to help you to better understand and master these steps, step by steps. And please waiting for our training video. And about the training video, I just mentioned that we will, after the training, we will edit this training video and we'll send it to our sales managers. So if you want this training video, please feel free to contact your sales manager from Dobot to acquire this training video. Is that okay? And about the question from our friend Goose, what is the maximum area size to scan? It depends. The vision system does not have the fixed values because the vision area of the camera depends on the install height and the camera that you use. It is a dynamic value, but this value you can check it on the Dobot Vision Studio software. It will show the vision area height and width. Once your camera install height and the camera is fixed. Okay, if there's if there is no further questions about the past training content, we then take a little break for 10 minutes, and then we continue the next part. Okay, my friends, we will continue our next training content part in 1 minute. Okay, so let's continue. And as I mentioned in the past, UDP is another communication protocol which is in the same layer as the TCP. And UDP is the user datagram protocol, which is used to process data packets like the TCP protocol. But unlike the TCP protocol, the UDP does not provide packet grouping, assemble, and sorting. That is to say, after the message is sent via UDP protocol, it is impossible to know whether it arrives safely and completely. So UDP protocol is mainly used when transmission performance rather than transmission integrity is emphasized. And if you want to know more about the UDP protocol, we also put YouTube introduction video link in this slide. You can check it after the training. And this table shows the UDP related API of robots. Since there are fewer scenarios where our robot uses the UDP protocol regarding the data integrity importance, I will skip the following content. And if you will use the UDP protocol in the future, you can view this content or contact us by email later. But as you can see here, the corresponding UDP related API is just the same as the TCP API, which is the difference is just the name. Okay, then we'll go to the second part, which is also an important communication method that's our industrial cobot works with, which is the Modbus TCP. And firstly, the introduction about the Modbus. So Modbus is a serial communication protocol used for transmitting information over serial lines between electronic devices, which is now the most commonly available means of connecting industrial electronic devices. The device requesting the information is called the Modbus master. and the devices supplying information are Modbus slaves. And in the standard Modbus network, there is only one master and up to 247 slaves. The line interfaces of the CR series supports communication over Modbus TCP for Ethernet, while the terminal interfaces include RS485 interface over Modbus RTU for serialize. And these two ports I also mentioned in our very beginning part of the training presentation. And for the detailed information about the Modbus protocol, you can check it later. The only one I will remember you again that the default Modbus ports of our robot is 502. And Modbus RTU is one of the versions of the Modbus protocol existing for serial ports, which is used in serial communication. And generally, it uses RS485 or RS232 connection. Modbus TCP is a Modbus variant used for communications over TCP/IP networks via the port 502. It is simply the Modbus RTU protocol with a TCP interface that runs on Ethernet. And in this slide, the typical questions about Modbus TCP and Modbus RTU are also showing, which you can view later. In standard Modbus protocol, the data is stored in the slave device in 4 different tables. 2 tables store on-off discrete values, which are called cores, and 2 store numerical values, which are called registers. The cores and the registers each have a read-only table and read-write table. The detailed descriptions of the cores and the register, as well as the defined Modbus function codes, are showing in this slide. And this table here shows the Modbus address corresponding to the core the Modbus functions. As you can see, the Modbus address normally consists of 5-bit data, including the initial data type, which is 1 bit, and the subsequent address, which is 4 bit. And this table shows the description of the Doorbot Modbus TCP APIs. And due to the time limits, I will skip the detailed description of the Modbus related API. If you are interested in it and you will use it in your application project, you can check this content after the training. And if you have further questions, you can contact us via email. And the many Modbus related API can be divided in 3 parts. The first part is create Modbus master or and disconnect. And the second part is read or write the core registers. And the third part is read or write the register. And now I want to show you an introduction video of how to achieve the Modbus TCP connection via the debug tool. So firstly, we use the Modbus creates API to create a Modbus master, and here we input the Modbus slave IP port and the Modbus slave ID. And for our CI robots, we support up to 4 Modbus slave creation. And in this example, as we use the debug tool or the Modbus slave simulator tool to act as the Modbus slave, so the IP address is same as the PC. Then we use the Modbus slave simulator tool to connect the Modbus TCP, to create the Modbus TCP connection by input the Modbus TCP server IP address and the corresponding port, which is the default port 502. Then click OK to connect to the Modbus slave. And by this script, we want to set the Modbus core, Modbus slaves core from the Modbus address 1000 and write 5 bits, and each value is 00001. So after we run in the script, we can see that the value is changed here. And by this API, we want to read the Modbus slave ports value of the Modbus address one from the Modbus address 1000 and only 1 bit. So that is the value of the Modbus course address 1000. and hence the value is 0. And once we set the value to 1, it will stop and go to the point P1 as shown here. And then the robot will continue reading the Modbus slave course address 1002's value. And if this value becomes 1, then it will print this string and go to the point 2, as shown here. We use the slave simulator to change the value and to 1, and it will go to the point 2. Okay, that is the main application or function that we can use via the Modbus TCP protocol to translate the data between the robots and the external device. Then we continue the next part. So about the Modbus slave or about the Modbus simulator tool, you can also find it in our Turbo Studio Pro software to do the debug if you want. And when the robot works as a slave, we use another Modbus simulator, which is the Modbus Pro. It can act as a Modbus master and communicate with the robot, which is the Modbus slave. It's just the same, and I will same steps and process, and I will skip it. So then we go to the last two parts of the TCP/IP content. Firstly is the TCP/IP customization and system integration. And in this part, we mainly introduce the robot customization and the system integration via TCP/IP protocol. As we all know, to remote control our robots, so run the offline saved project, we can use the remote I/O Modbus, remote Modbus, and also we can try to do the secondary development via the TCP/IP protocol. And there are several points you need to know about the TCP/IP protocol. The first one is to use the TCP/IP protocol, the controller firmware version needs to be above 3.5.1.9. And for the MG400 or M1 Pro robot, it should be above 1.5.3.0 to use the fully function API for the TCP/IP protocol. And according to our product design solution, the ports 29999 and 30003, 3004 server ports are available for CI robots to do the secondary development. And here shows the introduction diagram about how our robots designed for secondary development via the TCP/IP protocol or based on TCP/IP protocol. Through the 29999 server ports, you can input the integrated API strings such as enable robots or start robots, and to control the robots. And via the 30003 sub port, you can send the robots move instructions API to the robot to control the robot to move. And for the real-time feedback data port, it is the 4004 server port. About the detailed description of the integrated API based on the TCP/IP protocol, you can check this link. And in this case, we will show you some examples of how to use the server port 29999 and 30003 via the TCP/IP protocol. And the hardware you need to prepare is a network port, of course. And here, for example, we use the debugging tool integrated in our Doorbell Studio Pro software to receive and send the data via the string command via the server port. As I just mentioned before, that via the 29999 server port, you can send the strings to enable the robot or start the robot. And here is a mistake. To check the real-time data or receive the real-time status data of the robot, you can use the 3004 support, and the 3003 support is used to send the motion instruction command to the robot to control the robot move via the TCP/IP protocol. And about the detailed description of each functions, you can check in this link. As here showing, for example, we can control the robot via the debug tool to create a TCP client and connect to the robot. Here is, of course, the MG400 192.168.1.6, which is the default IP address of MG400, and use the 29999 support to send the corresponding APIs string. And besides the enable robot function, you can achieve like disable robots to read the robot mode via the 29999 support, and via the support 30003, as I just mentioned, you can send the motion commands string or API to the robot via this port to control the robot to move. And based on the TCP/IP protocol, our CR or MG400 robot supports users to do the secondary development of our robots via multiple programming languages such as Python, C, Java, Rose, and etc. And about the corresponding demos based for the certain programming language, you can check the description via this link. And here is a basic introduction about the secondary development via Python language based on the TCP/IP protocol. Firstly, you enter the website which we uploading our Python demo based on TCP/IP protocol. Then you download this demo code, which contains 2 Python files, demo py and robot API point Python. And for in the demo Python file, it contains you can edit the script, and about the robot API Python file, it contains our integrated function APIs, which you can use for your script. And the following slides shows the corresponding API that we integrated in our Python demo. And this is the file that you can edit your Python script program. And we also make a little test for you to get familiar with our Python demo here, which you can do it after our training. And if you have any question, you can also contact us to help you get familiar with it. Okay, I think the above content is all about our many used communication methods. And about our robots application, the many used 2 communication methods, as I just mentioned, is the TCP/IP and the Modbus TCP. And some of our users will also ask us if we support Profinet or Ethernet IP. So for this communication methods demands, right now we can, the temporary solution we provided to you is use the protocol gateway to change the corresponding communication protocol to Modbus TCP to achieve the communication. And in next year, we will default support the Ethernet in our CI robot. That is the information I want you to know. And now we go to the second part, which is the application of end effectors. Right now, our industrial cobot supports lots of accessories, such as scrapers, and force sensors, and etc. And this slide shows some of the main end effectors which are compatible with CI robots. You can see like the main gripper manufacturer like DH and RoboTQ. We both support both of these main grippers model. And here shows the communication protocol that we support to work with these grippers. And here shows the main technical parameters of our compatible grippers accessory, which you can check it later. And this slide shows the mainly used end effectors which are compatible with our MG400 cobot. The DHPG2 gripper, DHPGS5 gripper, and the mini vacuum pump box, which work with the grippers. And here shows the corresponding technical parameters. About the compatibility of the end effectors, if you want to confirm whether the end effector you are using can work or cannot work with our industrial cobots, we suggest you firstly check these 3 points. First point is check the mechanic specification of the end effector. So namely the flange of the end effector need to meet the ISO 9409 standard, which is the standard our robot flange use. And secondly, check the power source. Our robot will output 1.5 amp and 24 voltage. So the end effector has to be compatible with 24 voltage power source. And lastly, check the communicational compatibility, namely the communication protocol. The end effector needs to support the I/O or RS-485 to work with our robots. And if the end effector is controlled by terminal I/O, then it has to be NPN type with its digital input interface. And here shows the mechanical specification or requirements of our robot phalange. And during our experience, most phalange of the end effectors follow the same mechanical standards that our robot phalange supports. And this slide shows the interface diagram of the end effector. As I just mentioned, our CR series robot supports I/O and RS-485 communication method. And about the tool I/O port, its output is NPN type, which is different from the controller I/O, which is the PNP, and the input of the tool I/O is PNP type. This is very important when you want to use the end effector with our tool I/O. You need to check the compatibility of this point with your end effector. And goes with our CR packing list or a delivery list. We will send you an extension cable for the end effector port. And here shows the pin description of the tool I/O. And the next part of the end effectors is the communication. So the RS Modbus RS485. And for our CR robots, the end effector is using Modbus RTU protocol. So the RS485 port to communicate with our robot. And here shows an example of how to use our integrated related API to control the end effector via the RS485 protocol. And another thing I want to introduce you or to let you know, besides using the API based on RS485 commands, is that if you use the end effector that we are compatible or integrated in our Dobot Vision Studio, Dobot Studio Pro software, you can go to the Dobot Plus function model on the Dobot Studio Pro software and install the corresponding plugin package. After successful install, the corresponding API for this end effector will automatically show in the Broccoli or script programming, which you can use to control the end effector in your program. And for the detailed description of the related API, I will escape it due to the time limits. And if you are interested, you can check this PPT after the training. And if you have further questions, you can contact us via email. Okay, after introduction of the compatible end effector of our industrial cobots, we then go to the introduction about how to create the robot trajectory. Normally, we suggest you to use two methods to create the robot trajectory. First one is use our trajectory record and playback function to create the teaching trajectory files. The second method is use the CAD trajectory to import the point coordinates and in the form of Excel, and run this point in our script program. And here shows a video about introduction video about how to use our trajectory record and playback function. Firstly, you long press the trajectory record button, keep function button at the end arm, then manually control the robot to move, then short press the robot trajectory record function kit to create the trajectory file. Then press the playback function button to let the robot play back the trajectory you just saved. And at this part, we have already told you in the core function treaty. I will skip it. And as I just mentioned, another method to create the robot's trajectory to control the robot to move is import the CAD file in the form of Excel. So firstly, users can use CAD to draw a figure like a triangle, a square, or any trajectory that you want the robot move along. And then you can import the coordinate information of the points of the trajectory to an Excel chart file and save them locally. And about how to export the points from AutoCAD to Excel, we put an introduction video link here, which you can refer if you want. And after you export the CAD points information in the form of the Excel, then we added the format as the first is the X coordinates value, and the second is the Y coordinate, and the third is the Z value of each point. So this is point 1, XYZ, point 2, XYZ. And then you can create a script in the Adobe Studio Pro control software and copy the saved CSV file in this project. And you can run the script and use the IO open Lua command to import or read the coordinate values saved in the CSV file. Also, you can use our Sigma RTT tool software to monitor the whole trajectory. And some of you may have questions about how to input or copy the CSV file in the script project or program that you create on the Adobe Studio Pro software. And we can use the last part I want to introduce to you, which is a Simba protocol to achieve that. So Simba is the standard Windows interoperability suite of programs for Linux and Unix. As our robot controller system is programmed based on the Linux system. So if we want to access the controller system via the PC, we need to use the Simba protocol. as here. So in the situation that you want to access the controller system, the controller project, or to control or to connect your PC to our robot, CI robot, you need to firstly go to your PC Windows, turn Windows features on or off function, and enable the Simba 1.0 protocol, then click OK. It is necessary. And then after you enable the Simba protocol of your computer, your PC, you can press Win up to, and then input the default IP address of the robot. Here as MG400 IP address, for example, and which can help you to access the project saved in the robot controller. And when you first access this controller project, it needs you to input the default name and password, and as shown here. And another thing you need to notice that is, please make sure you check the remember credential box so that the software will gain free access to the file in the future. And after you successfully access the controller project, you click project, then you will find the project folder, which you can check all the saved script or broccoli program project in your robot program. And then, as I mentioned before, you can copy the SC file to the corresponding program project that you want to run. And in case there are some new users attending this advanced function training, we provide you two guides to help you to access our industrial cobot via using Double Studio Pro. So if you have any questions when you want to access our robot or connect our robots to the Double Studio Pro, you can check this guide. I think it will solve most of your issues. Okay, that's all about today's advanced function training, and they make the last Q&A part. If you have any questions, please feel free to type it in the chat area, and we can answer it.
Hi, Jimmy. Can I ask a question now, very quickly?
Yes, yes.
Just one information. I just a beginner with your product, let's say, and I'm trying to use Double Studio Pro and Double SC.
SC Studio, right?
Exactly.
Yes, yes.
The first question is, which is the difference between Double Studio Pro and the Double SC?
For our users, we deeply introduce our so firstly, Double Studio Pro and the Double SC Studio, they are both our provided control software. So functionally, it is the same, but currently we deeply introduce our users to use the Double Studio Pro because it is the one that we mainly developing and maintaining from now, and we just stop maintaining and developing the SC Studio.
Okay. And the other question is, I'm looking that I have not already available the robot here with me.
Mhm.
I'm trying to use a virtual controller, but I can do it only by SC, not with the Pro. It is possible to do virtual robot with Pro?
You mean virtual controller?
Virtual controller, yes.
That is oftenly asked question about the access of the virtual controller function via the Double Studio Pro. So currently we have developed the virtual controller function with our Double Studio Pro control software, but currently it is under our internal testing process. After we
Not
finish
released.
our internal test, we will open it to our customer to use.
Okay, so actually, if I have to practice myself, I have to use the SC because I can use the virtual robot there.
Yes,
It's the only way.
Yes, and once we publish the virtual controller function of the Double Studio Pro, we will inform it to all of our users via email to letting you know and use. I think if everything works well, it will publish in December.
Very fine, very fine. Last question, very little. With the SC, I am not able to move the tabs that I can open in two different windows because my require is to see in the same moment one interface, for example, the script or the block or where else, and in the same time the 3D environment to see the behavior of the robot. Is it possible or not?
Yeah. You mean you mean to open two windows of? You mean to open two windows of the Double SC Studio, and one is
Yes,
to
and
control
see
the
it
robot,
in the
and
same
one is to check. This function cannot be achieved via Double SC Studio, but it will be a new function published with our Double Studio Pro software.
Yes, because as you can imagine, as you can figure,
Yes,
it's not easy to move a virtual robot because you can see it. No, you have to move up and down from the page. Okay.
Yes,
in this moment I will work in this way, but with the new version.
Yes, we think it is indeed a helpful function for our users to use. So we add this function in our Double Studio Pro software, and I will report it to our product design team to push it to speed up the publish date. Is that okay?
Thank you very much, and thank you for the training, Jimmy. Bye.
Okay, and another example, I am Alexander. I just using the Jimmy's Zoom account.
Hi, Alexander. Can you hear me?
Yes.
Thank you very much for training as well. A quick question about the trajectories that we covered just now. Is it possible to send a trajectory file to the MG400? I know it's not possible to record the trajectory, but can we still use the same format? Can we reproduce the format of the JSON file and send it down to the MG400?
You mean your question is whether the MG400 robot supports the trajectory record and playback function?
Yes, I think so. The playback function at least.
Oh, okay. So, so this section is only supported by our CI robot, not for MG400. So for MG400, we only support teach and playback, which is you can manually move or drag the MG400 to the points of your trajectory and save the points values and use the move commands to achieve the trajectory.
Okay, thank you.
Mm-hmm. And about the question from our about the question from our friend Doc, can RobotDK be used to program the robot offline? So currently, according to my my knowledge, we many use RobotDK to do the robot simulation, and whether it is supposed to program the robot, I need to discuss this with my team, and I will get back to you via email. Could you please send this question via email after the training, and I will get back to you via email once we have the conclusion. Is that okay?
Yeah, that's good. I'll send it through to Casio.
Okay. Thank you.
Just another question, using the IO connection port on the end of the robot, does you have to have does a gripper have to communicate through the RS485, or can it just, if it's a simple gripper, can it just be using the IO communications?
I beg your pardon?
Did you
Sorry,
not get my question?
Yes, because I just didn't clear hear from you.
So you described how to use the RS485 communication protocol with the end effector.
Yes.
If it's just a simple gripper, can it just like be open and closed just using the IO ports 1 and 2 on the end of the robot?
Yes. You can use the terminal IO to open and close your end effector, such as grippers. You can achieve that.
So just a command just to go on off through that IO can be easily enough achieved.
Yes. If your end effector like a gripper supports that, you can just use the terminal IO to turn it on or off of your end effector. You can achieve that. Just to install, to connect the hardware wiring according to the tool IO pin. It's okay.
Cool. Thank you.
Thank you. And about the question from our friend Karin, that's run a program on MG400 offline using USB flash without connecting the PC? So firstly, the answer is no, because for our cobots, or for the for most of the cobots on the market, the program that you edit or edit via the control software like Double Studio Pro from us, it will shift in the controller of the MG400, which cannot be saved in the USB flash memory. So the answer is no. But for offline control, robot control methods, as I just mentioned in the training content, you can either use the remote I/O, use I/O wiring to control, to run or stop or resume the offline program, or use the Modbus TCP to run the offline program. That is, we provide our user to run the saved program in our either MG400 or CR controller program, offline program. Okay, and the last, okay, any further questions? Okay, I will give you another 5 minutes for Q&A part. If you have any questions about the whole training content about our industrial advanced function, please feel free to raise them up, and we will be pleasure and willing to help you. And for the friends who don't have further questions and are totally clear with today's training content, could you please do me a favor to type clear or good in the chat room to let me know that you just be familiar with today's training. It is very important from us. And if you have any demand or suggestion about our overseas online training, you can also type them in the chat area. I will mark it and report it to our training design team to improve our training in the future. Thank you.
Alexander, a last quick question, if I may. Not necessarily directly related to this, but do you publish a roadmap of the things that you're developing at the moment? You mentioned the virtual controller. That's something I'm really looking forward to receiving. And there's a few other industrial protocols which I'm looking forward to being made available on Dobot. I'm just interested to know what other things you have that you're working on at the moment and when they might be released.
I'm sorry, due to the audio condition, Singlo, I cannot clear hear from you. Could you please type your question in the chat room, and I can see it and answer you via unmuting. Okay, I see. You mean the future develop roadmap of our product in the future that we can publish. This information I need to check with our product design team. If they can give me some informations that I can send it to you. Okay, you mean the virtual, okay. And the virtual controller, yes, and the industrial protocol, okay. Yes, indeed, these are two major functions that our overseas user need to have in our next or future product version. I will ask my product team to see whether they have clear or fixed published dates, and if they give me confirmed information, I will send it to you, Mark. And could you type individually your email to me, and if I got the conclusion, I can send it to you via email. Okay, got it. Thank you, my friend. Yes. Yes, the question from our friend from Fushan, our double vision kits can be installed or can be worked with all the CR series robots. And if you want, please send email to us, and we can send back to you with our demo solution about the CR2D picking demo. Is that okay? Direct from Fushan. Is that do I pronounce it right?
Yes, sir. I will contact you by via email.
Yes, please feel free to contact us via email, and I will send the related documents to you to refer. We have too many cases. We have too many successful cases overseas about integrate the CI robots with our robot vision kit to achieve the, for example, 2D vision picking case.
3D
2D
picking.
2D. So for our basic robot vision kit, it can only support 2D vision recognition. For 3D, you need to seek for other industrial camera from Hikvision or other vision manufacturing.
Okay, you can help me regarding this one. I need to program this one using this double vision kit for this machine.
Yes, and if you need to some consultation about your project with efficient application, you can email us. We will try our best to help you, give some suggestion. Is that okay?
Yeah, yes. Thank you
Okay.
very much.
Thank you. Okay, I see if there is no further questions from your side, we are going to finish today's advanced training. And before that, let me please help me to do the last part review. And if you are satisfied with today's training, please type OK to let me know. It is very important to us to improve our future online training to you. Thank you for your friendship and warmness. And I just mentioned in the past, we will try our best to improve our training course to you online, and we are planning to improve and do the second version of our training course, which will publish to you in the start of next year. So if you have any demand or suggestion about how to improve our training course, please feel free to tap here right now or contact with us via email later. You are welcome, and we will appreciate for your suggestion and help us to improve our service. Yes, thank you. Great. Any further questions, please feel free to contact us via email. And our overseas tech support team is aiming to serve you, to help you successful. Your success is our success. And thank you for your time for today's training. And it's time to say goodbye. Wish you have a good day, and we will see you next time. Bye-bye.